So our next coordinate problem, and as you can see, it takes some paper, it takes some work being shown, but the calculations themselves aren't really hard, and they'll get easier the more you practice those formulas. So given a triangle with coordinates A at 2, 6, B at 8, 2, and C at 11, 13, find the midpoint M, so that's this formula. Verify CM is perpendicular, so we're going to use slope, and verify this. What does that mean? That means the length again, that the lengths are equal, which means we need to use the distance formula. So now that we have our plan and we know what we need to do, we need to graph this. So I'm going to go ahead, since I have that 11, 13, I'm going to make my coordinate system axes out here a ways so that I have plenty of room to graph my triangle. And the graph is really important because coordinate geometry is as much visual as it is anything else. So A is at 2, 6. 1, 2, 3, 4, 5, 6. Here's A at 2, 6. And I do like to put the coordinates on the picture because it makes it a little easier for me. B is at 8, 2. 2, 3, 4, 5, 6, 7, 8, 2. So here's B at 8, 2. And C is at 11, 13. So here's 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The nice thing is when you're doing these calculations and you go to graph them, if it doesn't look right or your midpoint or segment is way off the money and doesn't look close to what you're finding, you may have graphed something wrong or you may have done the calculations wrong. So it provides kind of a nice check. So the first thing we need to find is the midpoint of AB. Well, if I take 2 plus 8 divided by 2 and 6 plus 2 divided by 2, 10 divided by 2 is 5. 12 divided by 2 is 6. So hopefully if I go to 1, 2, 3, 4, 5, 1, 2, 3, 8. How about 8 divided by, see, I already found a mistake. 8 divided, not multiply, 8 divided by 2 is 4. So try this again. 1, 2, 3, 4, 5, 1, 2, 3, 4. And that was absolutely a way to catch my mistake because 6 was clearly not even on my picture. So I found my first mistake. There's my midpoint. I know that those are the same. Hopefully, I will verify that in a little bit. Verify CM is perpendicular to AB. So this is about slope. So the slope of CM. So I'm going to check the slope of this purple line right here. So 13 minus 4. Remember, I should have put these on here. 5, 4. 13 minus 4 over 11 minus 5. My slope is 9 over 6, which reduces to 3/2. My slope of AB is 6 minus 2 over 2 minus 8, which is 4 over negative 6, which is negative 2/3. What can I conclude? Therefore, perpendicular, because slopes are opposite reciprocals. So I've shown that work. What's my last step? My last step is verify that this piece is the same length as this piece. So really I'm looking at the perpendicular bisector theorem here because now I've proven this is perpendicular. I established M at the midpoint. If C is on that, these should be equal by the perpendicular bisector theorem. So now I have to find the distance of AC. So I'm going to say 11 minus 2, the quantity squared, plus 13 minus 6, the quantity squared. So I have 9 squared plus 7 squared. So I have 81 plus 49 which is the square root of 130. And if we're proving equal, just go ahead and leave it as that radical because they should be exactly the same radical. Don't bother with your calculator. I only did the calculator in the last problem because I had to take 2 times it, and we're not ready to learn about how to handle radicals yet. So now I have to find the distance from B to C. It better be the square root of 130 when I get done. So B to C, I have 13 minus 8 this time, quantity squared, plus 11 minus 8, quantity squared, plus 13 minus 2, quantity squared. So I have 3 squared plus 11 squared. So I have 9 plus 121, which is the square root of 130. Conclusion, therefore, AC is equal to BC because lengths are the same. So the work and this final conclusion are what's very important in coordinate geometry. Good luck with your homework.